We are going again. Okay, so the plan is to do, I think, 2 hours of work on the window manager before I go to sleep. So I'm gonna set my Brain FM timer. 2 hours. I need to swap my monitors around. You know, normally when I'm using my PC, I have a little small monitor off to the side. And that's what I connect my Sereno to when I'm debugging. But obviously, when we're doing this, we want to focus the main thing. The main event, so to speak. Okay, so in between this stream and the previous stream, I fixed a kernel bug with the killing of programs. That sounds bad, but trust me, it's fine. So you run the program before we would start many of our shell programs, and they sort of loop infinitely. So as I spawn more of these guys, we're getting to sort of very slower. If I do 1, 2, 3, you see this is 1, 2, 3, 4, 5, a very slow process now. But what was happening before, at the end of the last stream, is I would kill that program, but all the children would keep running. There wasn't a recursive kill, so the system would remain unusable, so to speak. But now we're up to speed again. And so the plan long term is to also just have scheduling where, like, you think on a typical Linux system or a Unix system, the process hierarchy doesn't mean that much, and you kind of don't want it to mean that much. Everybody's equal in terms of scheduling. It's this sort of equality thing. But here we actually have a process topology that means something, right? Where we have one window manager, and then its children obviously all the same priority, but the window manager should have higher priority. And so what that means we can do is we can have this like subdividing scheme where we say, okay, when we pick a process to run, I'm gonna roll a random number in the N64 range, and then half of that, you'd probably check the top half or something, but what you do is essentially you say, okay, 50-50 chance the root process gets to run first. And then if yes, then you check, does anybody want to run here? Okay, no, then we kick it down one to this other half. And then at every layer, you divide by 2. So essentially you have like the window manager gets to run 50% of the time at minimum. And then Unless it doesn't have anything to do, at which point you shift over. Oh. And then all the children run equally within that. So the plan is, well, so that would give you sort of, doesn't matter how many processes I spawn, my task manager to kill them, for example, is still like fast and easy. And that's good, we like that. So yeah, anyway, this is future speculation. Although, I probably need to do this in 2-3 weeks time. But I think where we left off is we actually want to draw something in this guy. So say I spawn one window. What I want to do is I want to create a frame buffer and then start rendering that in the window manager and be able to draw to it in the saver program. Also, this probably should be an N32. It's dumb to have things be N64s when they don't have to be. Probably. Oh, whoops. Ah. Here's what we're gonna have. We're gonna have, we reset this, and then there's a second thing, which is deep window got. And we'll sort of, I don't know. You never know. Everything I'm thinking of doing feels wrong at this stage. We're just doing something to sort of get a feel for things. You found my talk interesting ideologically. Well, that's a dangerous thing, that is. Anyway, so you get a window. Oh yeah, and then the window has this... What is a 4K times 4K? Oh, 1024 frame. I guess it would just be a... I've done the maths here on my PC. 48576. Oh no, even better. I'm being so dumb. I'll just do this. This is even better. Okay, so that's our dumb frame. Then we get this thing where when we create the window, we have to create a dumb frame. And also an associated like handle. So it's almost, you know, we have I believe this is just 4097. Oh, we forgot there was like a whole space thing here. Yeah. I think I have to call get global address space situla, which is not great. That's a temporary shortcoming, though. TTT, wow. Long time no see. What are you cooking nowadays? What are you working on? You probably told me, but I think I forgot. Oh yes, right. A hypervisor. Dude, I don't envy you. That's hard. Dumb frame alloc, and then we have the actual frame. I just want to set the default width and height to the sort of monitor resolution, which would be 800 by 600. For now, you're staying with a low profile. Well, see, and this is the funny thing. I don't even know what Kprobe is. So, it's amazing how specialized we can all become. Yeah, so 800 by... Because we don't want to, on the first frame, give like a crazy width estimate. Yeah, there's a bug here to be fixed as well, which is the last window. Is the frame? Yeah, the frame is there. K-probe enables you to dynamically break into any kernel routine and collect information. Oh, right, so you can like actually debug a kernel. I mean, yeah, that's useful. That's useful. Somebody might understand how Windows works if you do that. So instead of drawing with a color, I would like to blit let's try this though. Just make sure we get communication across the process boundary working first. So we have this whole you would do that and then this thing. Well, we have to go find the process or the so we're going to iterate all the workspaces and then every window in the workspace. Yeah. So if they have a matching PID, then we can return that. Actually, does it say on here the PID is? No. Well, that's something I need to fix. So here we would actually assign this guy window got, and we want that to be this handle, the dumb frame alloc. And then we break. So, okay, so the way this works, right, is we see that the PID window want is not equal to -1. That means there's an interprocess procedure call waiting. And then we set got. I'm just gonna copy these in case they don't exist down there. We set got to -1, we loop all the windows. If there's a match, you know, we set that. Otherwise, we just keep going. I guess if we wanted to be really strict. No, okay, it actually doesn't matter. Point is, we do. You know, in fact, if I'm gonna be really dumb, I would do this. I think it's. I have a feeling that this is the right style to be. Okay, so we loop over the things if we get a match, yada yada yada. And then we set this back to -1, so the only person who's allowed to set it to a non-1 value is this guy down here. What do we have? PID window want. Peep window, and that's not a spelling mistake, by the way. So point is, we are going to do this, where we say this is equal to from PID, and then while this is true, is it yield? That looks more right than this. Okay, and then when we have come out, so we set it, and then we loop. That means when we come back, we know that this other value has been assigned. Now, if we were on a multi-core system, which we want to be at some point, then you'd have to do this with atomics. But since we're on a single heart, there's some atomicity guarantees between when the context switch happens. Like almost by definition, the heart knows about its own rights. So if you do the write, and we in the compiler don't reorder things, so there's no issue there. So the point is, when this happens, we can read out and then I need to remind myself how this works. Where would this be? think it's in the shell, but it's like not used anymore. Oh, we could just look in the our dependency here. These are the syscalls, and I'm looking for a particular one. This guy. Okay, so what we care about is the give handle and success. Do that, and then we assert success. Because why not? Oops. And then this now will return an N64. Now this should be enough for us to do some magic on the other side. Let's check this build. Of course. Because I have to call up procedures to do this right now, and it's because that's sort of papering over something that's missing in the library system, the way particles are handled. Pages per chunk. But you know, sometimes you make it work with a certain system, and that's fine because you know that a certain system is sort of ready, ripe for rewriting at some point. N32 and N64. That's reasonable. In the new editor, I feel like I want to have go to line. That's useful when you have these errors. Or even the Casey Pilled Muratora. You know, you go to the byte offset. We could add that as well. We probably should add that. Okay, cool, that builds. So, let's take a look at the saver. So now the saver is calling Actually, it has a lot of the same stuff in here, but it's commented out, right? Well, it's running this and then looping. Well, okay, first of all, this now returns N64 by the magic of interprocess procedure calls. Now we have, you know, oh, we also need to copy this guy over. We don't really need this guy. We do that, and now we can say, you know, dumb frame So we map it, and then we get rid of this. Instead now, so in theory, all works well. We have shared memory established between the two processes. And then all we need to do is modify this width value occasionally so that it is nice and visible from the other side. We are doing very good on time so far. Okay. So if I run window manager, run the saver. That's very good, as intended. So the child process is writing over shared memory, and then we're getting this effect. If I start a second one, we get some goofiness. I think this is, oh yeah, so that's some screen tearing because we're doing this very slowly. There we go. It's very slow. And we have screen tearing. The screen tearing is because of that hardware thing. I had to fix in the kernel. But you know, that's to be done another day. I wonder if I imagine it's a little bit faster if I switch workspace. I mean, except for the fact that it's ridiculously slow, everything seems to be in order. The scheduling maybe isn't exactly fair, but the scheduling needs to be revamped anyway. Go over here at the status of these guys. Oh yeah, slowly. Let's just see if this guy number 3 eventually comes down. Because it seems to be missing. You know? Oh, that's interesting. Yes, there must be an order here where, so pink, I guess red, is going a lot faster than the teal underneath it, so it must be like higher up in the queue. These guys are fine. Okay. Let's try actually render what is in these frames. Let's first say, can we just put some cut? So we know this works, so we can then do, you know, hey, I'm going to set, you know, basic thing, counter. I guess you would do, yeah, you would say, Now I think we need to write a blitting function. Blitting procedure. Okay, I mean, easy naming here. Obviously, this is going to be called Blit Dummy. And it's going to have... We know it's 800 wide. So yeah, we know all the strides. Really, we just need the source, well, dest. Gonna have... Well, I can't remember if it's forward branches you're supposed to favor or not. Let me just double check that for the, you know, the super get everything right assembly autism. It's a skill, you know. You want to build the skill. Forward branch. Software should be optimized such that the sequential code path is the most common code path, with less frequently taken code paths placed out of line. Software should also assume that backward branches will be predicted. Oh, backward branch will be predicted taken and forward branches is not taken. Okay. So actually we have down here, there's an exit. And then, yeah, before you had to name these because they all went in the global namespace. So we have the while loop. It could be, yeah, I think for x86 they still go in a global namespace, which isn't good. But there isn't that much of that going on, so. Anyway, we have this while loop. And then branch equals 0. We're still a little bit instruction poor, so there may be cases here where we falter. So this is A0, A1, A2, A3. So the height is A3. Then if that's equals 0, then we jump to exit. This is a forward branch, so to be predicted not taken on the first try. And then on the jump back, we will just jump to while loop. Now I wonder, so our stride for the destination is 800 pixels times 4, which is 3200, which is, I think, slightly outside of the range of add I. But we could do that twice and add 1600. And then we don't waste an immediate. But maybe it's fine actually to have that in a register. So we'll say, yeah, T0 and T1 will contain our strides. Um, 1024 times 4 is obviously 496. So A add to A0 T0. Add to A1 T1. There's pointer and counter here. Which I guess is correct. A0, A1, A2, A3. Let's have these be A4 and A5. Oh, we actually need 2 pointers. Don't we? Well, no, because we can subtract. Ooh, this is interesting. We can subtract it from the pitch. So we can actually say, oops. Yeah, 1024, 800. Then subtract yeah, I guess it's width from both of these. Interesting. It's A2. Shift left logical immediate T0, T0, 2. Equivalent to multiply by 4. Pitch is minus. pitch jump. So now we can afford to just have a counter, which is going to be A4. And we have to be careful here. Isn't it everything? Might be under everything under S8, I believe, is saved, so we should be fine. But let's be safe and use S1 or S0. Actually, we can use A5. So the point is, here we're basically saying, you know, hey, vector unit, I would like vector units that have A4 number of elements. Can you give me that? And the vector unit comes back and says, no, but I can give you, say, you know, 32 or whatever. And then here we actually have to do a V. So we do a VLE into V8 of what would be the source A1, store into A0. What is this subtracting? Yes, then we subtract from the counter A4 whatever distance we went, A5 amount of pixels. And then we multiply So we remove this is in pixels, and now we want bytes, so we shift up by 4, and then we add that to both the destination and the source. A5. And then we check the count, I guess, yeah. Just A4. So we check A4. If A4 is not equal to 0, we have to do it again. And so we do the loop. We do the loop until the row of pixels is done, at which point we add the remaining pixels to get to the next side. Or back to the original points, and then we while loop again. So I think that's everything, and that ought to work. So what I want to replace this with split dummy What does frame look like? Noob frame. Right, pixels. Is this a pointer? No, it's by value. That's funny. Okay. Pixels plus win x. Times 4. Well, or upshift 2. And then oh, plus obviously the y coordinate times 800. The source is just gonna be dot frame dot pixels. Is this language a custom? Yes, it is a custom language. I think I'm on the 4th or 5th iteration of the compiler soon. What was this error? See, that should kind of be an autocast in my opinion. I'd fix that. So this either works or it doesn't work catastrophically, or it works pretty well. So we run this guy, we run this guy. Okay, no crash yet. Open a window. Blank screen, that's expected. Can I switch? I can't switch desktop for some reason. Can I exit? I can. Oh, interesting. That's a bug. The program has crashed. We just subtract A3. We're back to blue. I hit caps enter. And switch to another workspace. Oh. Oh, now I lost it entirely. Now we're gone. That's a kernel crash. We may have actually run out of memory because I bet we're actually kind of leaking like crazy. Although, yeah. Okay, I'm here. I had caps enter. Can I switch to another workspace? Yes, I can. This is very good. So it isn't crashing. And I see a little bit of blue pixel up in the top corner of the screen. I don't know if you can see that. We can get many of these spots. They don't seem to be growing. Oh, and that's a bug in the subprogram. Hold on. The most important rule of memory safety is to have fun. I mean, can you argue with that? Can anybody come up with a counterpoint? I forgot to increment counter. That's what happened. Okay, so now I open a window. Look at that. We get lines. And it sort of slowly fills up. And I can open more windows. And, you know, there's stuff in those windows. This is still feeling responsive, which is good. The key is... So when we get the new scheduling later on, the key will be that well, what would you say? The key, I think, to usability is that the window manager's scheduler or gets scheduled sort of at higher priority, and so we just let all the other programs stall in order, for example, to have quick workspace switching. Yeah. You know, so this is obviously working somehow. I want to get some... What I'm noticing now is with these black windows, I want to have a border around them. I think we'll do that, and then maybe next stream we will put some more interesting content in the saver. The saver program. I want to do like a screensaver with a bouncing box that smears and over time different colors, so we get like kind of a rainbow interesting effect going on. I think that'd be interesting to look at. But even if, you know, if it's a black window, you need to be able to tell that it's a window. So we need borders. And I guess borders count as gaps a little bit. Not quite, not fully. But a little bit they count as gaps. And so that's really, I feel like, adding value to our, you know, our Reddit post, the rice, which is, of course, the ultimate goal here. I need to get something to drink for my throat. Let's see if I can get this text going. I will be back in a moment. I have returned. Let's get some borders going. Oh, and I should turn the lights off so that maybe I can go to sleep soon. Thank you. I feel welcomed back. Now, I don't think these borders should be that crazy. If you think about it, there are... Well, first of all, let's... that's not what I meant to do. Let's sort of just... we need to shrink the windows a bit. So let's imagine we want to have... Because screen real estate is pretty scarce here. I think I want to do 2 pixels. Because we'll change its color like in DWM, and it's an important visual cue. So in the layouting, we would say if there's 1, this would be 2, 2, and then -4. Actually, this is -4 as well, because there's 2... It's interesting, an interesting question. I changed my mind. The way we do this is the windows stay the same, and then we draw the... It's just easier conceptually if we draw the borders inside the frames. So really we just say... here we do... you know, +2. Start off with that. So we have no windows, one window. See, that looks nice. 2 pixels, come on. Really, this should be 4x3 as well, like on a proper monitor. Okay, and then we got 2. Okay, yeah, and they are being drawn separate. So yeah, on the outer edge we have. Ooh, yeah, I mean, maybe you're actually right about the. Because the thing is, we get a 4-pixel border in the middle. But that might be necessary. Okay, and we can further subdivide this. Although it's not going to show because we're not drawing the actual borders. I wonder if I spam. Oops. I pressed something bad. That would be why. Those leaks. Those leaks. This is why this couldn't go to the public, right? Because first of all, we're doing prototyping. We're prototyping, the interfaces are going to be changing, and so it's going to be in an R&D stage for a while. And, you know, I get to do the thing, see how all the ways in which the kernel falls on its knees, and then that informs my kernel work. And then at some point later, we ship it to the people. I mean, the memory leaks are not hard though. It's honestly my laziness. Like the stuff we're leaking here is huge, and there's literally a list in the kernel of like, here are all the allocations that was made by this process. So there are just there's probably some like, as soon as we do the shared memory, then maybe it's not getting freed entirely. I mean, if I spam this thing, it's also, I mean, we're using this system for quite a long time between reboots, so I imagine there's a pretty good chance that it's just accumulated. Can I get it? Yeah, there we go. That's with borders. Now, why the first two don't have anything in them? Very curious. Feels like, yeah, so clearly there's some bug here where Windows 1 and 2 are not running. There we go, we get both, and if I try to do 4 again, only the last one fires for some reason. Curious. Curious. So if we decide we want to draw the borders, so I want the borders, and then I want like the way you move around the windows. Or did I do it on here? It's those spines. So for example, after that, I wonder how much did we leak? Quite a bit. Not good. Whoops. Oh, so there's no undo redo yet, so sometimes you just have to give up. That's why you exercise strategic saving. Why is it in Latin? Well, you know, way back when I was learning Latin, and I thought, why don't I apply some of my Latin to my programming? Maybe I'd learn faster. And the answer to that was yes, but also I had some very revelatory experiences of when you rename things in Latin, they somehow they lose this jargon effect where you can sort of just see through them a bit more. I mean, this is an effect of Latin more generally, but applied to programming, I thought it was just wow, amazing. And it's turned out to be more and more that way. Although I admit it's a little bit of a learning curve. But, you know, if you only know English and you have too difficulty, then that's a failure of me as a designer. Ah. So I want to use that, and then I have this active window to switch the border color on. Do we have any recommendations for border color? Probably they should be like logo in keeping. So like a dark blue. I guess we'll go for like a mid white. That's got a slight orange tint. How do you make orange? Is it like... Could it be something like that? Watch this be completely hideous now. I mean, we're essentially doing 4 of these. One for the top, where it's frame wide. I guess really 1 there, 1. Top, bottom, the right is down to, then is oh yeah, and all these should have border color. Oh yeah, there's also, I forgot to mention, there's an additional reason on the Latin. Why is it in Latin? Why is there a Latin theme? And that's that it's very cool. And that should be all the justification needed. Pink! What are you, insane? Maybe like a dulled pink or something. I think maybe I've adjusted to the DWM red. But I don't think I like it too much. I mean, I use Luke Smith's Lobs. So it might be that I've just adjusted. It might be, sorry, that he has configured it to be red. Don't actually know. That's true. So we're going all the way across my back to, yeah, Luke Smith mentioned. You know, in fact, just like his show is called, me and him are not related, even though we have the same surname. Well, in fact, actually, it's because of Luke Smith that I think, in part, it's because of him originally that I started learning Latin, and I also militantly do not regret it. Although I'm not anywhere near as good as he is. Cereal, okay, it's got okay calorie contents. As long as it's not like Fruit Loops or something. Then you know, you might be dying on the inside. $149. Cheerios, mid-range option. I mean, I think in taste, it really depends if it's the Cheerios. I think the sweet, like the honey Cheerios, are pretty fire. But I think they're the ones that are bad for you. Okay, so we run that. Do I get my borders? Okay, that is my bright border. And that is my dark border. Except I'm not doing it right, it seems. I don't know, I guess you're supposed to be gaining enjoyment from the screen. We're building an everything from scratch OS. And this is what you'd use for Windows. Oh yeah, you don't know. I guess you kind of know. But our interaction is not primarily you following this project. So at the bottom and the top, I think those worked. Maybe a bit, but you know, you'll get there. You know, there was this guy TTT who was here a while back, early in the stream, to say hi. And he's gone from like complete noob to now he's building a like hyper visor, something crazy. In, I don't know, a year or two, so he's done very, very well for himself. Okay, so we have this nice blue, and then we have the pink, which is not exactly what I intended. So we don't seem to be drawing the right side at any point. See if we can add, I want to like have binds to move around. So I'm going to hit J and K. That's not a Vim shout out. I'm not a Vimmy. OX11, OX12. You're going to see programming with overflow in action here. Okay, so the value of this is 0. Then if we minus equals, it's going to wrap. But then we just clamp it. Although this isn't going to work for the 0 case. So rip, I guess. Well, okay, there's an easy fix, which is just to say, you know, if wins.m, then this does something. And, you know, then we can go back to our sort of more basic, take this value. This value is equal to itself minus 1 mod win size. Oh man, we only have 5 minutes left, so I really need to get these borders down. Come on, there we go. Okay, so we have window 1. Oh, and on window 1, we're drawing the border too far left by 2 pixels. Useful to know. And yeah, I can move around my focus. There's no holding down though, that's good. I guess the layouting must be wrong. Okay, nice. That's one window with a working border. Now we have a failing border. Oh! Oh! I think I goofed. I made a serious goof. Because it looked like... I was drawing the thing like too far across. Oh. That's the issue. I have frame. Oh, right. It's okay. Wait. We're tight. Okay, so these are all wrong. Okay. That was it. The music stopped because focus time is over, but I think we might be golden. Okay, so we have this ugly purple background. It looks alright on the stream. For some reason, it's purple on this monitor. Oh, we ran out of memory. Moment of truth. Once we restart. So, Producta. Let me put it to saver. Try this. We get the ugly purple. Then we get a window with a border that's in focus. We get a second window. This guy's border is not in focus, but it's drawn correctly. I can switch between these. Very nice visual cue. And we have windows. Maybe DWM actually is correct to have a more subtle color, because this is a bit of a jarring change. Anyway, yeah, and then of course we can have, you know, workspace 4, we can have 2 windows here that we switch between. A solo window. It's a little bit confusing, I feel like, to not have a top bar. So maybe we should get a top bar. In theory, a top bar doesn't cost anything because we just render it to both frames and then we don't change it. Unless we change it. Like, you know, you can have a top bar and most of the bar stays the same. So you just have like, okay, when you switch workspace, redraw that bar that's at the top. I mean, it's fairly responsive this still, which is good. So yeah, because right now I feel like just the way my eyes feel like they're missing something at the top. Certainly a lot better than what we started out with. I wonder if I can, on my monitor, get this in 4:3 mode. Image, oh, there, it was there. Oh, there we go. So you can't see this on the stream, but I am now in 4x3 mode. And that looks very cool, actually. But maybe we should go down to 1 pixel of border. I'm a little bit conflicted. I mean, it's a not bad result, this, for about 4 hours of work or something. 4, 5, 6 hours total. Maybe 7. Maybe 7. We can have a fresh window. Be like, oh, look, this one has nothing in it, but this one does. To me, the ideal here is we need to be able to we need to be able to, so we need the top bar. That's important. And then we also need to be able to do full screen. But it's not the, oh, I can't wrap downwards. Interesting. Interesting. Why can I not? Oh, this is underflowing. That's just not the behavior I want. When you go up, you want a modulo. Here you want to say something like, really. I mean, honestly, a branch is, you're going to have a branch either way, I feel like. It's probably a way to do this branchless. Whoops. That music makes such a difference. It's amazing. And we don't even need the modulo now because we know it works. This -1. Yeah, I'm gonna give myself. Let's see, we'll put it at the top here. We'll do like a to-do list. So the bad thing about full screen in DWM, I think, is that it's like it's an Xorg full screen, which means you can't see other programs. So, and you can't switch them either, which is really bad. When I implemented a Wayland window manager that I used, you would have, if you full screen a program, that is just that's just saying like, hey, this takes up the whole space, but you can still flip through programs like normal. And so if a different, so you have basically the highest thing in the stack, right? We have, the thing on the left is the highest, and then it goes on the right downwards. The highest thing in the stack that is full screen gets drawn. And then if you are focusing some other window, you show that window on top. So this allows you to, for example, you can full screen both things and then flip between them. And you can also, like, I just think it's good. It's good way to do it. So anyway, we will have to do one is top bar. We won't add the numbers. We maybe even don't need to add, I think we don't have the, we could try and make a really thin top bar. I haven't seen that before. Yeah. So I'm thinking, yeah, we could have a very thin top bar that is just used to highlight, there are workspaces, which workspace are you on? These workspaces have windows in them. So that's like a signifier, important for you to look at them. Okay, yeah, so workspace indicators, and then full screen windows in a way that is good. Like Gateway was my old window manager project. Okay, and with that, I power off the device and I end the stream. Thank you for watching.